Hello everyone, this is Vardman and welcome back. Today we are going to start application of divide and conquer. The very first application will be finding maximum and minimum element in an array. The input for this will be an array of n distinct element and the output will be the maximum and the minimum element of that array. Before learning divide and conquer algorithm of finding maximum and minimum element in an array, let's first look at the normal way to find maximum and minimum element without using divide and conquer. First we have two variable max and min which are equal to the first element of an array which is a of I. Then we are iterating over the array starting from I equal to 2 which is second element of the array, and the loop will run a total of n minus time. So it will run from 2 to n. There is if else statement inside the loop. First we will compare if the current element which is a of I is greater than the maximum element. If it is greater, then the new maximum element will be a of I. In the second if condition, we will compare the current element and the minimum element. If the current element is smaller than the minimum element, then the current element will be the new minimum element. This will run a total of n minus time, and at last we will get the maximum and the minimum element, and we will return the maximum and the minimum element. Let's understand this with an example. Here we have initialized the maximum and the minimum variable max and min with the first element of the array which is 80. Now we will go inside the loop and the value of I will become 2. We will compare maximum with a of I. So here maximum is greater than a of I, so it will not change, and we will go to the else statement. In the else statement, 15 is smaller than 80, so the new minimum element will be 15. Now I become equal to 2. Here 200 is greater than maximum element, so 200 will be the new maximum. We will not compare with the minimum element because we already found the max element. Now the value of I become 4. We will compare 211. So 200 is greater, so we will not change. Now in the else part, we will compare 11 and 15. Here 11 is smaller than 15, so the new minimum will be 11. Now the value of I become 5. We will compare 200 and 250. 250 is greater than 200, so new max will become 250. Next, the value of I will become 6. We will compare 250 and 13. So 13 is smaller than 250, so we will go to else part. Here 11 is smaller than 13, so this time both of them will not change. Then the value of I will be incremented to 7. Here also 99 is smaller than the maximum element and 99 is greater than the minimum element, so this will not change. Now the value of I will become 8. So here 700 is greater than 250, so the new max will become 700. The value of I will become 9. So 3 is smaller than 700 and 3 is smaller than the minimum value which is 11. So the new minimum value will be 3. Now the value of I will become 10, and 115 is smaller than the maximum element and greater than the minimum element. So the value will not change. So the final value of max will be 700 and the final value of minimum will be 3. Let's check how many comparison we need. In the best case, if all the element are is in increasing order, then every time we will get the maximum element and there will be no need to go inside the else part. So there will be only one comparison for maximum element each time. So in this total comparison will be n minus 1. In the worst case, it will be reverse. So the array is in decreasing order. So the first condition will fail every time and we have to go to else condition each time. So every time 2 comparison will happen. So the total comparison will be 2 into n minus 1. Now we will take the average case. So we will take the best case half of the time, which is n minus 1 by 2, and we will take the worst case half of the time, which is 2 into n minus 1 by 2. So we will get an average case of 1.5 times into n minus 1. This comparison will be helpful when we look at divide and conquer algorithm to find maximum and minimum element. Now let's see the algorithm to find maximum and minimum element using divide and conquer. We will understand the algorithm by using an example and later we can explore the algorithm. Here is an example. So we have an array of 7 element and the index is starting from 1. We have one variable I equal to the starting index which is 1 and j equal to the ending index which is 7. So divide and conquer have 3 steps: divide, conquer and combine. First the divide will happen. So we will divide the array into two parts. For it, mid is calculated using floor of I plus j by 2. Left side will have element from I to mid and right side will have element from mid plus 1 to j. Let's try run the algorithm. So this algorithm will create a tree structure. So let's draw it. So we have our node and in this we have A, which is our array, and the starting and ending index. Starting index is 1 and the ending index is 7. Then we have two empty spot. So here we will keep the maximum and minimum element. So this we will get at the last. Now we will calculate mid, which is I plus j by 2 whole floor. So 1 plus 7 by 2 and floor. So this will be equal to 8 by 2 and this is 4. So we got our mid element as 4. Now the array is divided into two parts. One part will have element 1 to 4 and other part will have element from 5 to 7. So one part will have array A and element from 1 to 4 and two spot for max and min element. Second part will have A and element from 5 to 7 and two empty spot for max and min. Left side can be further divided. So here the mid will be 1 plus 4 by 2. So it will come 2.5 and we will take floor which will be 2. So in the left side we will have element 1 and 2 and the right side we will have element 3 and 4. Let's draw for left side. So it will have array A and element from 1 to 2 and two empty spot for max and min. And on the right side it will have array A and element from 3 to 4 and two empty spot for max and min. At this level we only have two element in each node. On the left side we have element from index 1 and 2 and on the right side we have element from index 3 and 4. So here we do not need any further division because we only have two element, and if we compare two element then one will be larger and other will be smaller. In general we can say if we have only two element or we have only one element at any node, then the problem is called small problem and that can be easily solved by one comparison. And if the node have more than two element, then the problem is called big problem and it need to be divided into smaller parts to get a smaller problem. So we will keep on dividing the larger problem until we get a smaller sub problem. Let's find the maximum and minimum for the element 1 and 2. So we have 10 and 80. So 80 is greater than 10. So the maximum element will be 80 and the minimum element will be 10. Now on the right side for 3 and 4, so 26 and 7. So 26 is larger than 7. Then we will get 26 as larger element and 7 as the smallest element. Then for element between 1 and 4, so we will take these or 4 values, and to find maximum we will only compare the maximum from both sides. So here we will take 80 and here we will take 26. So 80 is greater than 26. So the maximum will be 80. And now we will compare the minimum from both sides. So 7 is smaller than 10. So it will be the new minimum. So to finding maximum and minimum, we just compare the two maximum and the two minimum from the child node. To find maximum and minimum for the whole array, that is element from 1 to 7. So we got the element maximum and minimum from the left subarray, which is 1 to 4. And to get the maximum and minimum from the right subarray, we have to further divide the array. Now let's divide element from 5 to 7. Mid element will be 5 plus 7 by 2, which is equal to 6. So on the left side we will have element 5 and 6, and on the right side we will have only one element, which is 7. So these both are small problems with two element and one element, so we can easily find maximum and minimum with the help of few comparison. Element in index 5 and 6, which are 90 and 120. So 120 is larger than 90, so 120 will be the maximum element and 90 will be the minimum element. And on the right side there is only one element, which is 3, so it will be both maximum and minimum as well. So we will write 3 in both the slots. Now we have maximum and minimum from the child node, and now we can find the maximum between 5 and 7. We will compare both maximum and both minimum. So 120 is larger than 3, so 120 will be the maximum element, and 3 is smaller than 90, so 3 will be the new minimum element. Similarly, we got maximum and minimum for both child node for element from 1 to 7. We will compare the two maximum and two minimum for both sides. Here 120 is larger than 80, so the maximum element will be 120, and 3 is smaller than 7, so the minimum element will be 3. So here we get our final overall minimum for the array, which is 3, and the overall maximum for the array is 120. Now look at the actual algorithm code for finding maximum and minimum by divide and conquer. We have a recursive function divide and conquer min max, and inside it we have two if statement and one else statement. So inside the if statement we have our termination condition for our recursive function. In the else part we have our divide and conquer logic. It include finding the mid value and recursively call the function. So we are recursively calling the function two times, and finally we are returning the maximum and minimum. So this will be the overall maximum minimum for that array. Let's look how the function call will happen. So the input to our function will be array a, and I will be the starting index, which is 1, and ending index j, which is 7. Now we will go inside the function. We will check if the first if condition, which is I equal to j, here 1 is not equal to 7, so we will move to the next if condition. In the next if condition, if I is equal to j minus 1, 1 is not equal to 6, so we will also skip this and we will move to else part. This is the part where we will find the mid. So here we got the mid, which is equal to 1 plus 7 by 2, which is 4. So the mid element will be 4. The next step is calling the function recursively. Input will be array a and I, which is 1, and mid, which is 4. We will go inside the function again, here with different inputs a, 1 and 4. This time also both if condition will fail because I is not equal to j and I is not equal to j minus 1. So we will move to the else part, and here we will find the mid again. So here it will be 1 plus 4 by 2, which is 2.5, and we will take floor value, so the mid will be 2. Now the recursive function will be called again with the new values, that is a, 1, 2. We will go inside the function again, and the first condition I is not equal to j, but the second if condition will satisfy. So 1 is equal to 2 minus 1, which is 1. So we will go inside the if condition, and here we will compare both the element. If I is greater than a of j, so here 10 is smaller than 80, so we will go to the next part, and the max element will be 80 and the minimum element will be 10, and we will return this value to the previous function call. So we got max 1 and min 1 here. Now we move to the next step to find max 2 and min 2. Function is again recursively called, this time for the value a, 3, 4. First if condition will not satisfy, so we will move to the second if condition, and here it will satisfy. 3 is equal to 4 minus 1, and we will go inside the loop. So here a of I is greater than a of j, 26 is greater than 7, so 26 will be the max and 7 will be the min, and we will get the value of max 2 and min 2. From here we will go to next step. So we will compare max 1 and max 2. So 80 is greater than 26. So 80 will be the max, and on comparing min 1 and min 2, 7 is smaller than 10. So 7 will be the minimum. Here this section is comparing max 1 with max 2 and min 1 with min 2. So whichever is greatest will be the max, and whichever is the minimum will be the min. So for element between 1 and 7, we got the maximum as 80 and minimum as 7. So here in the tree you can see we got max 1 and min 1 as 80 and 10, and max 2 and min 2 as 26 and 7. And on comparing max 1 and max 2, we got 80 as the max, and min 1 and min 2 we got 7 as the min. Now look at the other part. So we have completed finding min and max for the array between index 1 and 4. Each function call will require min 1 max 1 and min 2 max 2 to find the overall maximum and minimum in this range. For function call A17, we have got the min 1 and max 1, but we also need to find min 2 and max 2. We got our max 1 and min 1 as 80 and 70. Now we will move to the other part. So we have returned to our initial function call, which is A17, and here the values of mid was 4. We will find the value of max 2 and min 2. For that we will go to the next line, and the function will be called recursively for values A57. We will go inside the function again with values A57. The first if condition will fail, 5 is not equal to 7. Second condition will also fail, 5 is not equal to 6. So we will move to the else part. Here we will find the mid. Mid will be equal to 5 plus 7 by 2, which is equal to 12 by 2 equal to 6. Now we will move to the next statement, and we will call the function recursively for value A56. We will go inside the function again with value A56. So here the first condition will fail, 5 is not equal to 6, but the second condition will be true. So 5 is equal to 6 minus 1, which is 5. Inside if 90 is smaller than 120, so max will become 120 and min will become 90. So we got our max 1 and min 1 as 120 and 90. Now we will move to the second statement. Here the function will be called recursively for value A77. We will go inside the function, and here the first condition will satisfy, 7 is equal to 7, and we will get both min and max equal to 3. So now we have both the values max 1 and min 1 and max 2 and min 2. Now we will compare them and find out the overall maximum for the array from index 5 to 7. So this part does that. So here 120 is greater than 3. 120 will be the maximum and 3 is smaller than 90. So 3 will be the minimum. Now we have both min 1 max 1 and min 2 max 2 for the entire array, which is from index 1 to 7. On comparing both maximum, 120 is greater than 80. So 120 will be the maximum. And on comparing both minimum, 3 is smaller than 7. So 3 will be the minimum. So we got the maximum as 120 and minimum as 3. Now let's look at the time complexity. So the first two if statement, they are only comparison statement. They will execute it when the problem is small. So they will only take big O of one time. In the else part, finding mid will take only big O of one time because it's just one division. And we are dividing the array into two parts every time. So these two functions will be called t and by2 times each. After function call, these statements will compare max 1 and max 2, min 1 and min 2. It will take big O of one time because they are just few comparison statement. We can write a recurrence relation for this. So Tn is equal to big O of 1 if n is equal to 1 or n is equal to 2. So when the size of the array is 1 or the sign of the array is 2, so we will need a couple of comparisons to get the max and the min. So first two if statement represent that, and big O of 1, which is the time required to find the min, plus 2t n by 2. So these two statement can be written as t n by 2 plus t n by 2, which is 2t n by 2, plus big O of 1, which is comparison. So these comparison will take big O of 1 time if n is greater than 2. This is when we have a larger problem. We will try to solve this reconciliation. So Tn is equal to 2t n by 2 plus c. So big O of 1 plus big O of 1 can be written as c. So we will solve this by master theorem. So we need to find Fn, and so Fn will be equal to c, and n raised to the power log base ab will be equal to n raised to the power log 2b will be equal to n. So by first case of master theorem, we get the time complexity of big O of n. Time complexity big O of n will be for every case. So now let's see what will be the space complexity. So we are using recursion, and recursion will create a tree-like structure, and we will be needing a stack to store the function calls. So the height of the tree will be log n. So we can say the space complexity will be the height of the tree, which is log n, and which is also the stack space. So space complexity is nothing but stack space, which is log n. On comparing finding maximum and minimum element in an array by using iterative method and by using divide and conquer. So time complexity for both will be same, which is big O of n. So the difference will be the space complexity. So normal divide and conquer will have big O of 1 space complexity, and divide and conquer will have stack space, which is log n as space complexity.